Well, in this case, I have a repeated linear factor. Here's what I do with that. You can do decomposition on that. Repeated linear factor. You get the same factor twice, linear-wise. Here's what you do for decomposition. So I'm going to do my decomposition here. So I'm going to take the 6x plus 7. It's already factored for me, basically, so nothing I need to do there. But here's what I do. When you have a repeated linear factor, that factor is going to lead to two terms over here, two parts over here. I'm going to have an a over just x plus 2, and then I'm going to have a b over x plus 2 squared. To get the decomposition to work out, that's what you have to do. You have to do one of them and then the other one squared. I mean, it wouldn't make sense to do x plus 2 and x plus 2 because then it would just already have a common denominator. You wouldn't. So to get it to work out here, that's what you have to do. For a repeated linear factor, you do just the factor and then the factor squared. You do two parts for it each time that happens. Okay? All right, so, of course, I multiply by this, right, both sides. And so when I do that, of course, you get 6x plus 7. And then the a over x plus 2 times that would give me a times x plus 2. One of them cancels, yeah. If you need to write it, that's fine too. But, yeah, one of them cancels, so you just have a times the x plus 2. Now on the b's, what happened? On the b side, the x plus 2 squared cancels, so you just have b, don't you? So we wind up with this, which, multiplying ax plus 2a plus b. And the first system we got was the hardest one because what do I wind up with here? As far as the x goes, I just have ax, don't I? So 6 and a, 6 equals a equals 6. Now the other two are constants. There's no x term on them, in other words, so that's 2a plus b equals 7. So I got a freebie there. Now I just have to plug in to get the b. 2 times 6 plus b would equal 7. That's 12 equals 12 plus b equals 7. Subtract the 12 equals negative 5. So there's my decomposition. 6x plus 7 over x plus 2 squared is going to go to 6. Let's do that up here. That's going to be 6 over x plus 2 plus negative 5 over x plus 2 squared. And that's where you could write the minus if you wanted to. Minus 5 over x plus 2 squared. Okay? So far? Okay. Well, since we wind up with that a little bit different there, second one, let's split it up here. Got x plus 2, 6 over x plus 2. And then I've got plus negative 5 over x plus 2 squared. Well, that's the same thing we've been having, isn't it? What is that one? That's just the natural log. That'd be 6 natural log of x plus 2. Is that one a natural log? The second one? No. Second one's not a natural log. What do I do with it? Well, it's also just a nice little u substitution. Think about it. Just let u be the x plus 2, du equals dx then. And so I'll have, with that substitution, just negative 5 over u squared du. which is just power rule, isn't it? It's power rule. 6 natural log of x plus 2. Yeah, that's just same as negative 5 u to the negative 2, isn't it? So it'll be negative 5 over negative 1 u to the negative 1 plus c, but then go back to your, yeah, that's just nice little, winds up being positive anyway. Be x plus 2 to the negative 1. So they won't always come out to be natural logs. Just how it all works out. We'll get some different stuff, definitely. Okay? All right. So these aren't too bad. So let's take another step here. All right, the integral 36 over x plus 5 squared times x minus 1 dx. Okay, so our decomposition there, what do you think? Well, we got that squared factor, and so that needs to be 2. So I'm going to have a over x plus 5 and b over x plus 5 squared. But then I've got another factor of x minus 1, so I need another factor 2. C over x minus 1. All right. Okay, so multiply this both sides. I get 36 equals. Well, one of the x plus 5 cancels, so I have a times, I have another x plus 5, and then x minus 7, a. One of the x plus 5 cancels. For the b, I've got that over x plus 5 squared, so the x plus 5 squareds cancel, so I have an x minus 1 times b. And then for c, what do I have for c? C would be x plus 5 squared. So I have to multiply that out to see what goes with what. This will be a, pull that out, x squared minus x plus 5x will be plus 4x minus 5. Of course, that's bx minus b. And that'll be c, x plus 5x plus 5, so that would be x squared, 10x, 25. So all total I have ax squared, 4xa, 5 bx minus b, cx squared, 10cx, 25c. So in this case, how many equations do I have? Well, notice here I have x squared terms, and I have x terms, and I have constants. So there's 3 equations here, and that's good because there's 3 variables. So you need 3 equations. All right, so let's go with the, so I've got, if you want to regroup them, it'll be a plus c x squared, right? What is a plus c going to be? Yeah, there's no x squared over here, so that's a plus c is 0. What about the x terms? We got x, x, and x. So I've got 4a B, and 10C. That's my X ones. And there's no X term over here, so all that also equals 0. And then last but not least, my constants, I got minus 5A, minus B, plus 25C. So all that, well, there is a constant over here, 36. So all that equals 36. Okay. All right, yeah, you run into those sometimes. Anybody see how to go solve that? Well, this one is not too bad. Couldn't I say C equals negative A here? One way I could go. And then make C be negative A in those other two. With me there? See what I'm doing? I'm just substituting negative A for C in these other two. Let's see what happens. They're all kind of different on how you solve them. This won't be necessarily the only way you could do these. Okay, so what have I got? I got 4A minus 10A, so that's minus 6A plus B equals 0. And I've got negative 5A minus 25A, negative 30A minus B equals 36. Hey, that's pretty good because you just add those two together, they cancel out. The B's do anyway. That's what I see anyway. Negative 36. Oh, look at that. Negative 36A equals 36. So it looks like A is negative 1. Well, if A is negative 1, then I have negative 6A. So I have negative 6 times negative 1 plus B equals 0. That's 6 plus B equals 0. That's B equals negative 6. And also, if A is negative 1, C is positive 1, isn't it? Because C is negative A. Okay. Let's go to A is negative 1, B is negative 6, and C is positive 1. What is that? A is negative 1, B is negative 6, and C is positive 1. All right? Okay, well, let's do it then. So I have the integral of negative 1 over x plus 5 minus 6 over x plus 5 squared, and then 1 over x minus 1. Well, I think we can handle all of those right there, can't we? We've done those before. This one, what's the first one? Natural log. Minus 1, natural log, absolute value of x plus 5. Second one, u equals x plus 5, yeah. Do the second one. Yeah, just let u equals x plus 5, du equals dx, and go with it. And then the last one is, well, the last one's just natural log of x minus 1, isn't it? Absolute value. That's minus ln of x plus 5. That would be negative 6 over u squared, or negative 6 u to the minus 2, so that's the same. Be minus 6 over negative 1 u to the minus 1. which is plus 6 x plus 5 to the negative 1. Now let me mention one other thing. Because what they'll probably do is, a lot of times, especially if powers come out to be these, those two, a lot of times you'll see those combined. How could I combine minus natural log of x plus 5 with positive natural log of x minus 1? Yep. These two can combine into that, can't they? Because basically they're the natural log subtracted. The others I didn't do because I had powers, and you can probably, I probably should have talked about them then, but just be aware they're using the log properties there to do that. Yeah, if you have the natural log of x minus the natural log of y, you can write that as 1 natural log as x over y. That's all we're doing. Just be aware of that. I'm okay with it here. The book might go one more. All right? Look at one more. Got one more for you. How are we doing on time? Ooh, we got plenty of time. Okay. The integral of 4x squared plus 8 over x squared plus 4 x plus 2 dx. First note on this one. Can I factor x squared plus 4? They call that an irreducible factor. In other words, that's true. Much better at math. Okay. Irreducible factor. What you do with that? We got 4x squared plus 8 over x squared. So I'm going to do my decomposition here. An irreducible factor is different than a linear factor squared, or just a linear factor, of course. Here's what I do with that. Yeah, I'm going to do x squared plus, the good news is I just need two fractions here. X squared plus 4, one of the denominators, x plus 2, the other denominator. I do just need 2 here. But with the irreducible factor, what you have to do is on top, it has to be a linear factor as well. Here's what I mean. You've got to have an ax plus b on top. Because the bottom, it's an irreducible factor, x squared factor. So that's what you have to do to the top there. Make it ax plus b. So that's a little different. Instead of just a number here, you are going to have a variable on the top. That's the way that works. And then the x plus 2, well, you just need a number c there. Okay? With me? Okay. So I multiply both sides by x squared plus 4x plus 2, so we get 4x squared plus 8 here. And I'm not sure what's going to happen over there. Well, the ax plus b is going to be multiplied by x plus 2, because the x squared plus 4 is cancel. And then the c is going to be multiplied by x squared plus 4. So we have 4x squared plus 8 equals, there's a little FOIL there, so that's x squared, 2ax, bx, 2b, and then cx squared plus 4c. So regrouping here, looks like I've got a plus c. That's equal to 4, right? So I need to write that out. A plus c is 4. I hope this works. Well, I've got some x terms, but they're going to be 0, right? 2a plus b equals 0. And then, last but not least, the constants. I got 2b and 4c, so 2b plus 4c equals 8. And then you just have to figure up on your own there, system-wise, what you need to do. Well, you got A and C, A and B, and B and C, so I'm going to have to do something. Looks like I could turn B over to A, couldn't I? Is that going to help me? Maybe not. Yeah, that'll help me. Couldn't I say here B is minus 2A? So then B is minus 2A right there. See another thing you can do. So we've got minus 4A plus 4C equals 8. Now I've got A plus C equals 4, minus 4A plus 4C equals 8. If I divide this by 4, that's going to go good. However you need to, but yeah, because then I've got this and this. Won't those cancel? The A's cancel. 2C equals 6. I got A plus C equals 4, and I've got minus A plus C equals 2. The A's cancel. So I have 2C equals 6. That's C equals 3. So C equals 3, then A plus C equals 4. That's A is 1. Well, B is minus 2A, so B is negative 2. Sound about right? So far, so good. I don't think I've worked this one before, so it's going good so far. So I've got A is 1, B, yeah, I might have to do, I know what to do. Okay, this one's going to work out. So what have we got? 1x plus B, 1x minus 2. So it'd be x minus 2 here. A is 1, B is negative 2. So that's x minus 2. With me? The C is 3. Okay. First one's the hardest one. But are you okay on that one? Up to this point. Okay? All right. Let me get rid of this because I'm going to need room. We got this? All right. If that's just our natural log, no problem. This one, a little bit of a problem. However, does this anything remind you of anything? Inverse tangent? Inverse tangent. That's what I thought you'd think. Okay. All right. Now, the only problem is for it to be inverse tangent, the top needs just to be a number, yeah. Or just, yeah, 1 or some other constant. So that's, all right. So So here's what I can do. Do you see here that I can split this up? I can do the x over the x squared plus 4, and I can do the minus 2 over the x squared plus 4 separately. Wouldn't that be a legal maneuver? I think that's the way it's going to work out here. I haven't done that one yet. So make this one into 2. Sometimes that might work. Sometimes there are other little tricks. But now, which one of those is the inverse tangent? The middle one, yeah. The middle one's going to be just the inverse tangent. What do we do about the first one? Well, let's just rewrite it separately. U substitution will pop its head just about anywhere. Can I do this one by U substitution? U is x squared plus 4. du is 2x dx. du over 2x, in other words, is dx. So that's going to work out to be x over u, and du over 2x. Aren't the x's going to cancel? So that one will work by u substitution. It's going to be a natural log. Right? That's the integral of 1/2 times 1 over u, which is 1/2 times the natural log of u. Absolute value. See all that? Now, our second one, x squared plus 1 is 1 over x squared plus 1 is inverse tangent. What about x squared plus 4? Well, you might have to refer back to the sheet, huh? Is that on the sheet? X squared plus a number. I think it's on there. I don't have the sheet with me, but pretty sure it's on there. Right about here on the sheet. Right about here. Show my audience there. Yeah, right here on our little cheat sheet. 1 over a squared plus x squared. Of course, we have what is it? The 1 over a. This is a squared. So a is 2, right? So it'll be 1 over 2. Tan inverse. X divided by a is 2. Yeah. So that was just a nice little tan inverse. You can do it with, well, that takes a little work, but the sheet has it right on there. And then this is natural. Oh, I forgot my 2, didn't I? Yeah, there's a factor of 2, so that does need to come down. Thank you. Plus. All right, so putting all this here together, this is 1/2 the natural log of u, so that's 1/2 the natural log of absolute value of x squared plus 4, but x squared plus 4 is always positive.